Hello everyone. This morning we are going to be doing lecture number 1 of the new unit 7, natural selection. Sorry, it's been a bit of a hectic morning, so I'm trying to get it together and get this done. So what we've learned so far, we've learned that there's biodiversity and that it has changed over time. We've learned that population sizes of some species have fluctuated, and we figured out some causes for that. But is it possible that these two ideas are connected, and can changes in population sizes play a role in species change? Well, let's see. So I'm going to tell you about 3 interesting stories. Okay, the first one being the story of the peppered moth. The peppered moth is a night-flying moth common in the northern hemisphere. They are most commonly found resting on the trunks and branches of trees. There are 2 different color morphs for the species. They're speckled, which looks much like the speckled chicken that we talked about last unit, and dark. So in 1850, there was mostly speckled moths, and the dark was the rare form. But in 1990, mostly dark was more common and speckled form was rare. And currently in the year 2000, we're back to speckled being the more common kind. Okay, so in box 1, you're going to summarize a story. Okay, so remember in the early 1900s, there was something happening called the Industrial Revolution. Okay, so prior to the Industrial Revolution, the trees had a white and black pattern, so the moths would be able to blend in. But after the Industrial Revolution, the trees became coated in coal. They now had this dark color on them. So the black colored moths had the advantage of blending in, and the white moths would have stood out more and they would have been eaten by predators. But now in the 2000s, when we don't have trees that are covered in coal because of the machinery we are using, the speckled moth is more common because the trees are back to their normal state. So take a second and summarize that. Use the years, use the word speckled, use the word dark. Remember, you can press pause and keep going, but I'm going to keep rolling, okay? The story of bacteria. So Staphylococcus aureus is a bacteria that normally lives in our skin. It is harmless unless it enters through a wound or scrape, so basically any broken skin. S. aureus can cause a range of illnesses from minor skin infections to life-threatening pneumonia, meningitis, and even sepsis. So this is a key term, antibiotic. Antibiotic is a medicine that stops the bacteria, that stops the growth of or destroys bacteria. Remember, you can always press pause. So in the 1880s, S. aureus was first reported. In the 1940s, penicillin was introduced for medicine use. By 1942, the first isolation of penicillin-resistant S. aureus existed. So that meant that penicillin was no longer effective to this bacteria. By 1959, methicillin was introduced for medical use, and within a year, 80% of all S. aureus strains are now resistant to penicillin. By 1961, the first report of methicillin resistance. Okay, so we're getting a new medicine. The bacteria is developing resistance. We're getting another one, and once again, it's developing a resistance. So resistance means that it's not killing it as effectively. Okay, it was once poisonous to it, and now it's not really doing anything. And by 1968, there was the first outbreak of methicillin-resistant S. aureus. So if we don't have medicine to fight the infection, then unfortunately that poor person is in for a world of hurt. So take a second and summarize the story in your own words. The story of the finches. The medium ground finches are found only in the Galapagos Islands off Ecuador. Many researchers have been interested in these birds since Darwin's time because of their beak variations. Okay, so in 1976, the average beak depth was 9.2 millimeters, and in 1978, it jumped to 9.7 millimeters. So record these down. Average beak size has changed, but the individuals there's still variation, right? So if you look at the averages, the average has increased, but there's still some that are larger and still some that are smaller. Key term, variation, small differences in the population. What do these three stories have in common? Write down your thoughts. Unfortunately, you can't share with a partner because you're at home. Share it with mom, dad, sister, brother, maybe? I don't know. Okay, so we just identified a naturally occurring phenomenon. Okay, so box B, traits in a population change over time. So this is the naturally occurring phenomenon. Okay, traits in populations change over time. And now, trait, a characteristic determined by genes. Remember, if you need time to write this down, hit pause. Okay, so traits, there's a huge variation of traits. I mean, look at just this, okay? Some of you guys can roll your tongues, others can't. Some of us have widow's peak. Some of us have attached earlobes or unattached, hitchhiker's thumb, mid-digit knuckle hair, dimple chin, freckles, Morton's toe. There are so many different variations in the human species, right? And these are only a couple. So now we're going to ask our big question for the unit. So box C, why do traits change over time? Why do you think that happens? Okay, please note this down. And that is the end of today's lecture. Please double check the agenda to make sure there's not any other assignments you're supposed to be doing, and I will see you guys later.